Welcome to True Projects. In this video, we are going to explain about a project titled Cotton Leaf Disease Prediction using the Deep Learning. The project introduction highlights the influence of global warming on the increased occurrence of pest and disease in local crops, which resulting in reduced agricultural output. The study specifically centers on cotton, a vital economic crop which frequently faces the threats from various pests and diseases during its growth. The main objective is to enhance the detection of the cotton leaf disease and pests through the application of the deep learning technology, specifically the ResNet 50 model. By leveraging it aims to create a powerful model capable of accurately classifying the cotton leaf illness. The main goal of this project is to enhance the detection of the cotton leaf disease by employing the deep learning technology, specifically the ResNet 50. The aim is to create a highly accurate model capable of classifying the cotton leaf illness and pest effectively. Additionally, the project seeks to address the influence of the global warming on the rise of the disease in the local crop, which negatively impact the agricultural production, resulting in lower quality yields. These are the basic requirements that are needed to build this project. Software requirement: Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, the necessary Python libraries such as NumPy, Pandas, TensorFlow, Keras and the Flask are imported. These libraries are essential for tasks like data manipulation, deep learning model building and web development using the Flask framework. And the second one is exploring the dataset. The dataset containing the cotton leaf images which thoroughly explored to understand its structure and the characteristics. Exploratory data analysis involves visualizing the image, checking the dimension and understanding the distribution of the different classes within the dataset. And the third one is data augmentation. Data augmentation is a technique that are applied to expand the dataset and improve the model generalization ability. This involves creating the augmented version of the original images by performing the transformation such as rotation, flipping, and zooming. The data augmentation helps in preventing overfitting and enriching the training data. And the fourth one is splitting the dataset to the training and the testing. To evaluate the model performance accurately, the dataset is split into the two subsets, the training set and the testing set. The training set is used to train the ResNet 50 model, while the testing set remains unseen and is employed to assess the model's generalization on the new unseen cotton leaf images. And the fifth step is building the model. Here, we are building this model by using the ResNet 50, using the Keras, which is a powerful pre-trained deep learning model designed to extract the intricate features from the images, has proven effective in image classification tasks due to its deep architecture with skip connections, which help to mitigate the vanishing gradient problem and enables the successful training of the deep networks. And the sixth step is training the model. Here, the ResNet 50 model is trained using the augmented training dataset. During the training, the model learned to recognize the pattern and the features specific to the different cotton leaf diseases, enabling the accurate classification. And the seventh one is user gives the input. To interact with the trained ResNet 50 model, a web application is created using the Flask framework. The user interface allows the user to upload the cotton leaf image for the prediction. And the eighth one is the given input is pre-processed for prediction. When the user uploads an image, the input image is pre-processed to match the format used during the training. This involves resizing the image to appropriate dimension and performing any necessary normalization or scaling. And the ninth step is trained model is used for prediction. With the pre-processed user input, the trained ResNet50 model is employed to detect the type of the cotton leaf disease present in the input image. The model processes the image using its learned parameters and provide a prediction based on the feature it has extracted. And the last step is final outcome is displayed. The prediction outcome indicating the detected cotton leaf disease or pest is displayed to the user through the Flask web application. The user can see the model's classification result, providing the valuable insight into the health status of the cotton plant. This information can be crucial for the farmers and the agriculture expert to take timely and appropriate measures to mitigate the impact of the disease on the cotton crop. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of the different files within it. The images folder is of the dataset containing of the training and the validation images containing of the two folders within it, each one having the images within the each folder. And the input content of the images that will use it to give the input, and the sample folder containing of the images that will be used for testing the model performance, and the static folder containing of the various folders within it as CSS, JavaScript, images, models within it, and the template folder containing of the HTML documents contains of after, home, index, sign in and sign up pages within it. An app is an py file which contains the information related to the front-end logic. It includes the code that written in Python that handle the server-side operations such as processing the user requests, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the cotton leaf disease prediction is an IPYNP file which contains a combination of the code, graph and output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And the signup.db is a file appear to be the database file used to store the user information. To execute the project, we build a Flask framework, and the total code of the project is present in the IPYNP file in the form of graphs, code and output all in one place. For the execution of the project, first we need to copy this part of the code folder and then open the Anaconda prompt. Here we need to change the disk location as of F because our code folder is in present in F, and then write a command cd space paste this code folder address. By this command it will change the directory path to the code folder's path, and then click on enter button. After this we need to write another command python space app.py. By this command it will execute the Python script and perform the runtime check for any syntax errors or the logical issues, and then click on enter button. After running the python app.py file, the Flask framework will host the application locally at the default address of this, and we need to copy this local address and then paste it on any web browser. I preferably use the Chrome, and then paste the local link and then click on enter button. Here this is the home page of this project. Here we can see the sign up button. By clicking this, it redirected to the sign up page containing of the various details that are need to be filled to create a new account. But my account is already registered, that's why I'm using the sign in button. It redirected to the sign in page. Here we need to enter the username and password as of admin, and then click on sign in button. Here it redirected to this index page containing of the choose file and the upload buttons, and we need to click on the choose file button. It redirected to this sample folder containing of various images within it, and selecting any one of them image from it, selecting it and then click on open button, and then click on upload button. Here it redirected to the result page and predicted the leaf as having diseased. and click on the try again button. It redirected to the index page containing of the choose file and upload buttons, and then click on the choose file and select any one of the image from it, and then click on open button, and then click on upload button. The predicted leaf image is a fresh one. In this way, we can predict the cotton leaf by using the ResNet 50 deep learning model. And in conclusion, the project uses deep learning technology, specifically the ResNet 50, can significantly improve the detection of the cotton leaf disease. The developed model achieved and best accuracy in classifying the autumn leaf illness and pest. The research suggests that this technology can be used to improve the quality of the agricultural production and reduce the impact of the global warming on crops.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.